Coach Jay, what's up? This is podcast 4.1B AP Stats in the house. Hope you're doing well. This is for the weekend, right? For Monday. Please be sure to get down notes, write down notes, follow the notes on the screen, read a little bit. I'm going to give a little problem at the end to kind of have you do just to see if you can understand what's going on. So if you could do that, that would be fantastic. And we'll rock and roll from there. So please get notes down. Write it down, watch the podcast. We'll rock and roll from there. You ready to go? I'm ready to go. Let's get this show on the road here. Okay, let's do this. I want to make sure that we're all good here. Okay, I'm going to write down on this and we'll rock. Okay, so with this example, we kind of left off on other sampling of the sample surveys here. Talked about what does it mean to sample well, right? And so what we're going to focus on here is, I'm going to change this on that side, go a little red. So this is where we started, right? So we're going to look at sample surveys. Remember that when we talked about this, we talked about an error that is made of taking a sample. Oh, hold up. I'm sorry. Way back. I'm sorry. Wrong start. We were right here. Here we go. Other sampling methods here, okay? We talked about how when we divide it into strata, we said that's very important, right? Remember when we talked about this, when we have strata, we have like different like mini clouds, right? And within these mini clouds, some of them are referring to, well, we have different things, right? Some of them are going to be like, let's say we have strata of freshmen, sophomore, juniors, and seniors, right? And say we were talking about let's do the retreat, right? We got their opinions. We want to be representative of the entire population. So what we're going to do is we're going to have what we call a SRS within each of these strata, because we want to make sure that each strata is represented. Maybe we take a random, randomly we take 10 freshmen, sophomores, juniors, and seniors, or maybe 20, right? If we increase the sample size, will decrease the variability of what the true population's experience was at the retreat, right? So when we take each of these mini clouds and come together, we have different strata that come together to form what the sample would be in terms of the opinion of the population. When we call that a stratified sample, okay? And again, a good example of this would be like classes, freshman, sophomore, junior, senior. We could do gender. We could do socioeconomic, right? You could also do race. Any of these would be proper in doing there for different strata that are there, okay? The second one we have, a sample which is found by dividing the population into groups, then selecting an SRS from each group is called a cluster, okay? This is a cluster. All right, each group should mirror the characteristics of the population. That's very important, right? So we want to make sure that each of these are representative of the population that is there, okay? So a good example of this would be, as we looked at this, an example of this would be like, I've got it down here. Homerooms would not be, per se. I would say be careful on homerooms, because each group should mirror the characteristics of the population. This might just be like seniors here, right? So we want to make sure we probably had homerooms where we had freshmen, sophomore, junior, senior, guys and girls, right? I think I used the example of advisement. Let's say we use advisement where we brought guys and girls together from all 4 different classes, and then we said, okay, a cluster would be, we divide all of these up, right? Each of these are representative of the population, right? We know that. And what we would do is then take, instead of having groups from each one of these, like up here, like we take an SRS from each one, what we would do is we would take an SRS overall. And we would say, okay, out of all of this here, okay, out of all this, which cluster are we going to choose? So out of all of this on this side, right? Out of all this here, okay, we would say, I want to kind of get this here. All right, so hold on just a second. I'm trying to get this. Perfect. I would say, okay, which of these clusters would I choose? So as long as each of these are representative of the population, maybe I say, okay, out of the 5 clusters that are here, I'm going to randomly choose this and this one. So this homeroom and this homeroom, maybe this is Coach Johnson's and this is Coach Meeker's, right? And we would just choose that there. A sample in which one selects successively smaller groups within the population and stages, we call that a multi-stage sample. Multi-stage sample, okay? An example of this would be a presidential polling, okay? So again, we successfully get smaller groups within each population, right? So we choose a population and then we get smaller and smaller groups and stages. This is called presidential. This is like an example would be presidential polling, right? Another example would be the sizes of states, right? Another example of this would be SRS of counties. Okay, so something like that. Again, it gets smaller, right? We have multiple stages to that sample, but these are 3 ways that we can have proper sampling methods here. Okay. Now let's go to this here. I would like for you to try to see if you can figure A and B out. Okay. I want you to think about this. If you could pause this and try to see if you can figure it out. And I'm going to actually go into it right now. And so if you want to try it out on your own, but I'm going to go right here to it. Okay. All right, the first one says the athletic department is considering a stratified random sample. What would you recommend as the strata? Well, this is easy, right? Because you've already got it set up as far as the 3 different sections, right? So you got we've got the sideline, we've got these 4, right? We've got the corners and then the end zone, right? So what I would do is divide it up into these 3 strata. Once I do that, in order to find the sample of those, a good method of this would be, okay, if we're trying to figure out the within the concessions that are sold during games, right? To try to figure out what about the concessions? Do you like it? Is it too expensive? But if we're trying to get a survey, we want to try to mirror the entire population. So what you could do is divide each of these up into strata, strata 1, strata 2, strata 3. And then after that, what I would do is I would take an SRS of each. So let's say that I was trying to sample, let's say we're trying to sample 100 within each, so 300 total. I would sample an SRS of 100 each, okay? So I would take that, sample that, right? And once I do that, what I would do is I would maybe have one person here, like we would just go all over the stadium, right? Until I got 300. But we would do 100 within the sideline, 100 within the end zone, right? And 100 on the corners to be 300 total. But we would take 100 from each of the different strata or sections, okay? B says, explain why a cluster sample might be easier to obtain. Well, I would, to be a cluster, I think it might be easier. Because what I would do is, if you could, in Michigan Stadium, it's maybe harder to see here. But let's say that row 1, and I'll do this in yellow, obviously, because it's Michigan, right? We're going to say that this row 1 is all the way around the stadium, okay? And in Michigan Stadium, there's a ton of rows. Let's say there's like 100 rows, okay, all the way up. Do you see how in each of these, actually, I want to back up, because this right here would not be indicative. Well, kind of would. I guess we could do it that way. Yeah, let's say that we have each one of these rows. So you have all the way up, let's say there's 100 rows. And let's say that we randomly select one of those rows. So let's say we get row 50 or row 88. And let's say we do 3 different rows and we just literally go all around. Do you see how that's a clustered form? What we have over here is it's not as much strata because each of these rows, let's say row number 1, has all 3 within it, right? We have the sideline, we have the corner, and we also have the end zone seats, right? Each of these rows have all of the different strata that are inside. So let's say this is row 1, and we go all the way to 100. Then what we would do is take an SRS of the rows, right? And once we take an SRS of the rows, we would take those rows, and it would be maybe a little bit easier because everybody would be together, and we can just go kind of down the rows and then kind of go from there. Another thing we could utilize is the sections, right? So what we could do is put all of our sections in here. So section, every one of them within the stadium. And then we could take an SRS of those sections. It would be a lot easier to do that, not a convenience sample, okay? Because we're still, in this case, instead of going like within part A, you would be going all over the stadium. That'd be really hard. Whereas part B, we could divide them up into clusters based upon section and then take a simple random sample of those clusters. Those clusters within those sections are representative of the population. And because of the fact that you give an equal representation to each section, the chances are that, again, the more obviously samples you take, the closer you'll get to the actual population that's there. But what you could do is also sections. So you could do like a row. You could also go, probably the better one would be divided up into sections there, okay? All right, so with that being said, let's go into these notes that are here, okay? We got one page of notes here. You'll see it on that side. So let's go. We will always use a sample to give us information about the population. So the sample gives us information about the population, okay? That makes sense. The process of drawing conclusions about a population based on the sample, that is called inference, okay? Now, here we go. I will talk about this in class on Monday, but this is the Holy Grail right here, okay? The Holy Grail. And I'm pointing to the left because right over there, on the wall, we have the Holy Grail we've been talking about for the longest time. But the sample allows us to infer about the population, okay? Because we infer information about the population from what we know about the sample. Again, as long as this sample is a good representation, that's a good word, representation of the population. That's the key, okay? All right? Drawing inferences about the population from a poor sample is misleading. We call that bias, right? All right? Poor sampling techniques include voluntary and convenience sampling, okay? And you can put sampling after that, that, okay? Sampling, all right? So that's what we're putting in here. Money, all right? A good sample always utilizes random sampling, okay? We call this an SRS, okay? SRS. So that's what we're looking at there with inference. We pretty much have already done this, but really we haven't used the word. But inference, that's a huge, huge, huge deal, okay? Huge deal. So make sure you kind of have a good idea of what we're doing there, okay? All right. Now let's keep going here. Let's go to the next one. I think there's one more slide. Does it go all the way to the end here? Perfect. I think there's one more that I missed at the end, but that's right. Okay, an error that is made in the process of taking a sample that could lead to inaccurate information is called a sampling error, okay? Put that there. That should make sense. So an error that is made in the process of taking the sample. A good example of this would be, do you remember the drug test they were talking about? It's kind of funny. When they said like, well, what happens if something happened to the urine sample, right, of someone, and it got lost? The process of taking the sample, or let's say that they didn't have their P's and Q's and T's and I's all kind of squared away, and they messed up the process. That's called the sampling error, okay? So a sampling error could be the use of bad sampling methods. Again, an example of that would be, again, saying it again, it could be the voluntary or convenience, right, that we utilized in class, right? Voluntary, where people volunteer themselves in the study, or convenience, where you just do what is convenient, and it isn't an actual representation of the entire population there, okay? Awesome. A sampling error could be also a problem with the list of individuals that we use to select our sample, all right? So this is called sampling frame, all right? And again, this is when some groups in the population are left out of the process of choosing the sample, okay? So they don't have an equal representation. right? There's no equal representation here. And if they're left out of the process, we call this undercoverings. Undercovering, my fault. Undercovering, all right? A good example of this, I'm trying to, let's throw this down here. A good one is like, okay, here's a good one. So a good example of this is like a phone survey, right? So let's say that it's off the home phone. So let's say we're trying to conduct the survey of, hey, do you like the new QT, right? That's what we're trying to do. But we go to our home phones. The problem is I don't have a home phone, right? So those without a home phone are left out of the error. That is a sampling error because of the sampling frame. And because of the fact that people are left out and it's not representative of the entire population, we call that undercovering, okay? Undercovering. See if I got another example here. Yeah, so like household survey, right? So if I have a household survey, the problem with that is people who are homeless, right? Are they surveyed? They don't have a house, right? So if I come in and give a survey at your house and I'm just doing different individuals within the house, people are left out of this process of choosing. Therefore, we call that undercovering as well. Another example is if we're looking at GAC, a representation of GAC, and let's say they have a huge, well, let's say their senior skip day, okay? Let's say you skip school. And at that point, you were left out of the survey. We would call that undercovering because you were not able to be a part of that survey there. We call that undercovering there, okay? All right, an error that is made after the sample has already been determined, that is called a non-sampling error, okay? Non-sampling error. Hopefully you can see this here, okay? Yeah, so non-sampling error. So it's after the sample has already been determined. So the one before, remember, was a sampling error. It was through the process of the sampling. But after the sample has already been determined, that is called a non-sampling error. It's kind of what you do with the information where you mess it up there. This is when an individual when an individual who is chosen for a sample cannot be contacted or refuses to participate. That's called, that's just a non-response, okay, that has occurred, okay? This, again, is an example of a non-sampling error, okay? Again, you can't really, some of these things you're going to have regardless, right? When you do a phone survey, that's the problem with these is sometimes phone surveys, people won't contact you or they'll refuse to participate. In that case, we call that a non-response, okay? Non-response has occurred. That doesn't mean it's completely obliterated. That doesn't mean the survey's washed out, but we just got to take that into account when we display our results there, okay? An example, we said it already, no response on phone call, okay? Or they refuse, right? Another example is, let's say you're doing GAC, coming back to this example back here with the, this right here. Let's say you're right here and you come here to each of these sections within GAC right here, freshmen, sophomore, junior, seniors. A good example of this is, let's say that we try to get the SRS within each of our strata in this stratified random sample here. And let's say that there's a couple of seniors that say, you know what, I don't want to do this simple random sample. I don't want to waste my time. So they end up saying, you know what, I'm not doing this. We call that a non-response, okay? And again, that's what we're looking at there in what we're talking about here. Last two here, this is a systematic pattern of incorrect responses in a sample survey leads to response bias, okay? So again, this all goes back to after the survey or after the sample has already been determined. So we've said, okay, here's what we're going to sample now, right? We're saying, okay, these individuals we're sampling, what we have is a non-response right here, right? And then we have a response bias where different people provide incorrect responses or information, right? Some of you may have done this before when you are surveyed at a specific restaurant or something. You'll like put all ones or you'll put all fives. You don't even look at the information or the questions. You just put whatever you just want to be done with it, right? So that would be an incorrect response. We call that response bias. Again, all of these go back to the sample. After the sample has been determined, that, okay, these individuals are part of the sample. That's where this comes into play. The other one is where the process of taking that sample, right, as we choose the SRS, remember that's where a lot of the voluntary and convenient sample come back to the process of taking that actual sample that's there, okay? All right, awesome. And again, be careful, the sample are the individuals we're choosing, right? So this is, again, the process of choosing the individuals, right, or the sample. And this is the process, once we've chosen them, sometimes we get a non-response, and sometimes we get incorrect responses that are there. I think there's one more there that I forgot. In a sample survey, careful attention must be shown to the wording of questions. This is huge, okay? This is our last one. The wording of questions is very important, okay? Be careful. Wording of question. I'm trying to see. Oh, here's a good one. Ready? Let's say that in Coach Jay's class, okay, he gives a bonus on a test. And the bonus on the test is, this is yes or no. Okay, yes or no question. Don't you think that Michigan is the best team? Now, some of you, I'm telling you, some of you would just out of spite say no or you whatever, okay? But do you see the bias behind that? Don't you think that? I've already kind of set them up for this, right? A good example of this is if you go to, like, let's say we have a question on, actually, I think there's one on here. Let's see, I think this is an example. I'm going to go back here as we wrap this up. Remember this one? We said, if you had to do it over again, would you have children? The fact that you say, if you had to do it over again, right? And the whole idea of the way the wording, the question is worded, could that initiate a response, okay? So we want to word our questions, the questions that are here, right? We want to be non-biased, and we want it to be to where it's where the it provides the actual opinion of the individual without having a specific agenda that we're trying to get across there, okay? All right. Well, I hope that was helpful for you. Here's what I would like for you to do, okay? In fact, I'm going to do this one more. I'm going to pull this back up one more time. And I want you to try to do the following question, okay? This one made sense here. I want you to do this one. And I would like for you to try to do this one just as an example of one that kind of relates to what we were talking about today. Go over 1, 2, and 3. And before the quiz, if you do have a question on that, and I'll throw this up here. I'm sorry. You see my lovely face, not that. All right. I want you to try to just throw this up there and try to do that by yourself. So obviously you watch the podcast, which is awesome. I would also recommend you go through and just make sure you understand these 3. And if you don't, come on in the morning on Monday, and we'll look at those together. Hey, thank you so much. Have a phenomenal, phenomenal day. Peace out, AP Stat.